You know, have you ever stopped to think about how an AI actually reads a document? I mean, we know it's a wizard with words, right? But what about everything else? The charts, the tables, the images, all the stuff that really tells the story. How is an AI supposed to get the full picture when it's basically blind to half of the information?
So here's what we're going to dive into. First, we'll unpack this idea of AI's multimodal blind spot. Then, we'll look at a new way to build a unified knowledge framework. We'll get into the weeds of a really clever dual graph solution, see how it holds up when we put it to the test, and then we'll look ahead at what this all means for the future of AI understanding.
All right, let's kick things off with the core problem. Today's AI models, they're absolutely incredible at handling text. You can give them a book and they'll summarize it, ask a question, they'll find the answer. But our world doesn't just run on text, does it?
I mean, really, it all comes down to this simple question. A PDF looks so simple to us, right? But for an AI, it's like a minefield of different kinds of information all jumbled together, and it just wasn't built to see it all at once.
And this slide right here, wow, it just says it all. On the left, you've got a page from a financial report. It's rich, right? It's got charts supporting numbers, logos, the whole deal. Now look at the right. That's what a text-only AI sees. Just the words. All that incredibly important visual context, poof, gone. It's literally like trying to understand a movie with your eyes closed. So the tech that lets an AI answer questions about things happening right now is called Retrieval Augmented Generation, or RAG for short. You can think of it as the AI's personal, super-fast connection to a massive, live library. It's what keeps the AI from being stuck in the past, only knowing what it was trained on. And here is the big catch. This amazing RAG technology was basically built on one giant assumption, that all the useful knowledge in the world is written down in text. And that creates a huge bottleneck, because we all know that in the real world, the most important information often isn't in a sentence. And look, this isn't some academic what-if problem. This has massive, real-world consequences. Think about it. In scientific research, the big aha moment is almost always in a graph. In finance, the market trends are right there in the charts. And in medicine, life and death information is sitting in scans and data tables. When an AI skips over all of that, it's not just missing data. It's missing the entire point.
So what do we do about it? How can we possibly teach an AI to see the whole document, the words, the pictures, everything all at once? Well, it turns out the answer is to build a whole new kind of framework from the ground up.
This quote really gets to the heart of the new idea. It's about a total shift in thinking. Instead of seeing a document as a bunch of separate things, here's some text, here's an image, here's a table, this new approach sees everything as interconnected pieces of one giant puzzle. It all works together.
So the mission becomes pretty clear. Build a system that just doesn't care what kind of data it's looking at. It needs to be able to understand how a paragraph is explaining a chart, and how that chart is visualizing data from a table, and how an equation connects it all together. Okay, so let's pop the hood and see how this thing actually works. At the core of this new framework is a really elegant idea that gives the AI a much more sophisticated way to organize what it knows. Basically, a smarter, more connected brain. It really boils down to three main steps. First, the system takes the document apart, just breaking it into its basic building blocks, your text chunks, your images, your tables. Second, it builds these two interconnected knowledge graphs. And finally, it uses a new hybrid way to go find the information it needs. So this dual graph thing, what is it? Okay, imagine you're creating two different maps of the exact same city. The first map shows the physical layout, where the buildings are, how the streets connect. That's the visual structure of the document. The second map shows the semantic meaning, what kinds of businesses are in those buildings, what ideas are connected. By linking those two maps together, you get this incredibly rich picture of both what's there and what it means. And this slide just illustrates that perfectly. On the right, you've got your standard, old-school knowledge graph. It's just connecting ideas from the words. But look at the left. That's the cross-modal graph. It's so much richer, right? It's mapping how the text connects to the images and how those images connect to the tables. Fusing these two views together, well, that's the secret sauce.
Okay, so that all sounds fantastic in theory. It's a beautiful idea, but, the big question is always the same. Does it actually work in the real world? Let's take a look at the results.
And the short answer is, oh yeah, it works. The results aren't just a little bit better, they are dramatically better. And what's really cool is that the biggest improvements show up exactly where you need them most, in those long, dense, super complicated documents that are a nightmare to get through. Okay, now check out this chart. That blue line, that's this new framework.
The orange line is the old way of doing things. See how on short documents, they're kind of close? But then look what happens as the documents get longer and longer. The old methods just plateau or even get worse. Meanwhile, the new framework's accuracy just keeps on climbing. It's not even a fair fight.
And let's put a hard number on that. For documents that are over 100 pages long, we are talking about a more than 13 percentage point jump in accuracy. In the world of AI development, an improvement that big, it's absolutely massive.
All right, so numbers on a chart are one thing, but what does this actually feel like? Let's use a real-world example that makes the difference crystal clear. So here's the challenge, a super dense financial table. And the question seems simple, but it's tricky. Find the specific number for wages and salaries, but only for the year 2020. It's a classic needle in a haystack problem.
And here are the results. It's night and day. The old models, they just get confused. They grab a number from the wrong row, or they start adding things together that don't belong. But the new framework, bam, it nails the exact value. And the reason why is because it doesn't just see numbers. It understands the table's structure. That understanding of structure is the key to accuracy.
So this is clearly a huge breakthrough, a massive leap forward. But, this isn't the end of the road. The journey to an AI that can truly understand anything and everything still has a few interesting hurdles left to clear. Yeah, there are a few things left to tackle. First, even these new systems sometimes have a built-in bias for text. They'll trust a paragraph even when a perfect chart is sitting right there. Second, really weird, creative document layouts can still throw the AI for a loop. And finally, those messy tables in the real world with merged cells and weird formatting? That structural noise still requires even smarter tech to figure out.
But as we start to solve these final challenges, it all leads to this one, really big and incredibly exciting question. Just imagine, for a second, an AI that doesn't just read the words, but truly understands every single chart, table, and diagram in every scientific paper, every financial report, every medical study on the planet. If an AI can finally see the whole picture, what massive, complex problems are we finally going to be able to solve?